Yes, sir.
Yes, sir,
This meeting
properly.
is being recorded.
Yes, sir.
Okay, thank you.
Good evening, sir.
Good evening. So, कल हमने क्या कर लिया था? We have started up to okay. So we are starting now. Yesterday we were discussing. This is your Kirchhoff current law. Okay. So we have seen that algebraic sum of currents at any node is 0. And now the second basic law we are starting. This is Kirchhoff's voltage law. So what this law says, that algebraic sum of voltages, okay, algebraic sum of voltages across any closed loop is 0. Okay, what do you mean by this? So suppose before I discuss this law, okay, let me discuss you when you are moving in a loop, okay, in a closed loop, you come across the voltages, okay, like this. Suppose if you have a battery or source, and you are moving, if you are moving from negative potential to positive potential, okay, so negative potential is always less than your positive potential. That means if your current in, you are moving in a loop and you are finding you are moving from minus to plus, so that is called voltage rise.
सर किसी का माइक ऑन है?
Please,
Rajkumar.
please,
Rajkumar का mic.
Rajkumar, please see your mic. Okay, so this is called your voltage rise. Okay, now similarly, if you are moving in a circuit, okay, from, if you're moving opposite to this, okay, if you're moving from a higher voltage to lower voltage in a circuit, that is called your voltage drop. Okay, voltage drop. The voltage rise means you're going from lower potential to higher potential, so that's a rise. And if you're moving from higher to lower, that is voltage drop. Okay, similarly happens in resistance. If you are moving from higher to lower potential, that is will be voltage drop. Okay, and if you're moving from opposite to, if you're moving from lower potential to higher potential, this will be your voltage rise. Okay,
Sir, but resistance doesn't have a polarity, no?
resistance doesn't have polarity. That means I am telling, if you are voltmeter, this is a polarity, means how you are measuring voltage at that point. Are you getting? So if in a circuit, if you're moving in current direction, okay, of course this will be your higher potential, this will be lower potential. But if you're measuring the reverse way, that will be polarities. Okay, that's sign convention, you'll understand what I'm trying to say here. Okay, so now suppose if I have a circuit, okay, so I have a circuit, say I have one source, say this is V1, okay, say I have one more source, say the voltage drop here is say V2, okay, and I have one more resistance where I'm getting some voltage drop, say V3, okay, and I am putting one more source here in opposite directions. Say this is my V4, and I have an element in the circuit, okay, where I'm saying the voltage drop is again here, say V5. Okay, so two minus are there, so let it this is V4, V5 plus 2 minus V5. Okay. Now I want to write KVL in this loop. So how can I write KVL? Okay. So there are two ways to write KVL in the KVL equation. Either you consider voltage rise or voltage drops. Okay. So if I move from minus to plus, there is this is a voltage rise, and if I move from plus to minus, that is a voltage drop. Now it is your choice whether you want to take voltage rise as a positive or voltage drop as a positive. Okay, that is your choice. If you're going minus to plus, you can write this is a positive, and if going from plus to minus, you can write as a V2 as a negative, because this is a voltage drop. Okay. Now other way is there, that you, when you go for voltage rise minus to plus, okay, you take it as a negative, and voltage drop you take as a positive. Are you getting what I'm saying? Either you take V1 voltage rise as a positive or voltage drop as a positive. That is your choice. That nothing will happen. Same equation will come. So generally I take voltage rise as a negative, because there is a less chance probability of doing mistake, because whatever sign will come, I will just mention that sign. For example, in this it says algebraic sum of voltages across any closed loop is 0. So suppose I have a n voltage drop is, okay, so K equals to K should be 0. Anyone, somebody mic is on.
Sorry, sir, bad mistake.
So now if I write this equation, so I can simply write minus V1, whatever voltage sign will come, I'll come across, I will mention that sign, minus V1, okay, plus V2 plus V3 minus V4 and plus V5 equals to 0. If I write this V2 plus V3 plus V5 equals to V1 plus V4. Okay. Now this all V2, V3 and V5, they are voltage drops. Okay. They are voltage drop. So this is sum of voltage drops, sum of voltages drop is equal to sum of, okay, sum of voltages rise. Now let me explain this once again. Okay, so what I'm saying, you can write voltage rise as a negative or voltage rise as a positive. Okay, so I am, what I generally I write voltage rise as a negative, so that gives me flexibility. Okay, I don't need to think much. Whatever sign I come across, I'll put that sign in the equation. Okay, and I write the equations. So if you want to make voltage rise as a positive, just take minus common. This will be V1 plus V1 plus minus V2 minus V3 plus V4 minus V5, and the same equation will come. Okay, are you understanding what I'm saying? Are you getting what I'm saying, students?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes, sir.
So voltage, always sum of voltages and sum of drops are same. Okay, so basically this law is a law of conservation of energy, because your voltage I can write as a V by Q. Okay, Vk upon Qk equals to 0. So if I write this is a summation Vk is equals to 0. Okay, so that shows that work done moving a charge in a total work done moving a charge in a circuit is 0. Okay, so this is basically a energy conservation law. Energy conservation law. Okay, so let me solve one problem. So I'm starting with a simple circuit. Say I have this plus minus 20 volts. Okay, and I am just giving two resistances. This is 2 ohm, 3 ohm. Okay, plus minus plus minus. Okay, now same circuit. Okay, I am solving another way. I am giving two by battery. Okay, I am putting 2 ohm here, I am putting 3 ohm here. Okay, 2 ohm, I'm measuring plus minus, and here I'm measuring minus plus. Okay, now let us learn how to apply KVL in this two
Sir,
situations. Yes.
sir, resistance may how you are able to see that left side I will do plus and right side I will.
See, whenever current travels in a resistance, okay,
Yes, sir.
current always moves from higher potential to lower potential. Okay, so your
Yes,
plus
sir.
this point is always higher potential, and this is lower potential. This is higher potential, this is lower potential. Okay, so
Sir,
In second circuit, how you have done minus
and
plus?
second circuit, see, when current, I told you current is drawing, this will always move from higher potential to lower potential. But if you are measuring, right, you want voltage. Okay, suppose this voltage is V1 and this voltage is V2. Okay, this voltage is V1 and this voltage is V2. If you want to measure opposite way, okay, you don't
Yes,
want to
sir.
measure like this. If you want to measure like this, then
Yes, sir.
this they both will be equal and equal in magnitude and different in direction.
Opposite in the. Oh,
Yes.
okay, sir.
Okay,
Okay, sir.
so
sir,
yeah,
but how negative come there means you are deciding it now whether it is a positive or
now
negative.
how can I decide? I cannot decide. Na? It
So
will
it
all
is different.
current always flows from higher potential to lower potential. Okay, so if this, so if you want to, so this is always higher potential, this is lower potential, this is higher potential, this is lower potential, this is zero potential. Okay, this is a 20 volt. Okay, some drop will come, you will voltage, then again drop will come, and then you finally get a zero voltage which is connected to battery. Okay, so similarly here the current is flowing. Okay, so this is always higher potential, lower potential, higher potential, lower potential. But in exam they may ask you like this, tell me what is this one. Okay, this is just a polarity, how you're measuring. Okay, so say let us apply this in the same thing, and you see how they are connected. Apply KVL in the loop. Okay, say I current is flowing here. So if I want to apply KVL in the, so whatever I will start from first voltage, this will be my minus V. Second is plus, so I'm writing V1. Second is V2, so I'm writing V2, and that equals to 0. Okay, now what is my V1? My V1 is I R1. So current is I, resistance is 2, so this is equal to 2I. Okay, and my V2 is equals to what? Similarly, same current I is flowing in the circuit. Okay, so V2 is simply 3I. Can I write like this?
Yes, sir.
Okay, now put these values here, minus 20. Okay, so this will become 2I and plus 3I. 5I equals to 20. Okay, and I equals to what? 4 ampere. Now you have I equals to 4 ampere, so you automatically you know what is V1. So V1 कितना हो जाएगा मेरा? V1 will be 8 volts. Okay, and V2 will be 4 into 3, 12 volts, isn't it? Okay, so we have a total 20 volts, and this voltage is dividing here. Okay, here 8 volt in this one, and remaining 12 is here. Total 20 volts is dividing. Okay, now let us see what happens here. How do you write equations here? Okay, so apply KVL. Okay, so again same thing, you write minus 20. Okay, minus 20. Here you're getting plus, so write plus V1. Okay, and here you're writing minus V2, so you write minus V2 equals to 0. Okay, again what is the value of V1? If you assume the current is I,
2I,
you can write 2I, and what is the value of V2?
3I.
3I. 3I or minus 3I?
So
Minus
minus
3.
minus 3.
Minus 3I, because I told you yesterday how to apply Ohm's law. If we are moving like this, if you're moving lower to higher potential, then the Ohm's law when you apply, that will be V equal to minus IR, not plus IR. That's 3I. Okay, now again put the values here, minus 20, V1 is 2I, V2 is minus 3i minus plus 3i equals to 0, 5i equals to 20. Again, I is same value, 4 ampere. Okay, now what is my V1? V1 is again 8 volts. And what is V2?
12 volt minus 2.
Minus 12 volt. Okay, minus 12 volt.
Sir, voice.
Sir, voice.
Sir, your voice
Sir.
is gone.
Sir, you are not audible.
Message.
Sir, you are not audible.
जय सर ऑडियो नहीं आ रही है.
Am I audible now? Okay.
Yes sir.
So, if this point is clear, what I'm saying? That
सर आप लास्ट को जो बोल रहे थे ना वो वहां से कट हो गया.
so I'm saying the drop is same. पहले भी यहाँ पे 8 वोल्ट था, यहाँ पे 12 वोल्ट था. Okay, now still again here is 8 volt, here is 12 volt. Voltage drop is same. Okay, that but I'm measuring I'm measuring different way. Here I will get, if I say V2 here, V2 here is 12 volt and V2 here is minus 12 volt. Okay.
तो जब हम इसका टोटल करेंगे तो सम का मैग्नीट्यूड का सम करेंगे ना, वरना तो फिर -4 वोल्ट आ जाए.
हाँ, वो ड्रॉप तो 20 वोल्ट ही है, यहाँ तो हम मेजर अलग से कर रहे हैं ना,
ओके
मेजर उल्टा कर रहे हैं. ओके,
ड्रॉप V2 इक्वल टू 3i कैसे लिया एक बार बता दीजिए.
हाँ, V2 इक्वल टू 3i कैसे लिया भाई? whenever I told you yesterday, okay, the Ohms law convention is there. Okay, so this is your R and this is your plus minus. Okay, if is current moving from higher potential to lower potential, okay, so you write V equals to always IR. Okay, and somehow if you force to current to move from a minus to plus, if you measure voltage like this, not see, if you measure voltage like this, you have plus minus. Okay, you're measuring like this, so your V is always IR. Okay, now same thing if you measure, your current is moving like this and you try to measure drop across these points like this. Okay, so V equals to will be you will get minus IR. जैसे ये का मल्टीमीटर है भाई तुमने मल्टीमीटर का ग्राउंड यहाँ लगा दिया और ऐसे मेजर किया तो आपको ये देगा डिजिटल मल्टीमीटर, और आपने उल्टा मेजर किया तो आपको उल्टा देगा. बस बात यही है, मैग्नीट्यूड अलग लगाएगा आपका मेजर करने पे, सेम थोड़ी आएगा अगर डिजिटल मल्टीमीटर यूज कर रहे हैं तो.
सर
हाँ,
केसीएल में हम माइनस V2 लेते हैं, वहाँ एक बार हम साइन कन्वेंशन का ये करते हैं, थीम करते हैं, उसके बाद ओम्स लॉ में भी हम नेगेटिव मतलब
भाई यहाँ तो सीधे सीधा है, जो लॉ है वो लगा दो आप. माइनस आ रहा तो माइनस लगा दो, प्लस आ रहा तो प्लस लगा दो, माइनस आ रहा तो माइनस लगा दो. ओके, फिर then when you put voltage, calculate Ohm's law, then you have to see whether you're moving from you're measuring like this or you're measuring like this. Okay, so let me solve one more problem. Okay, then things will be more clear to you. Okay, say I have a circuit here, plus minus 60 volt. You have 10 ohm here, okay. 8 ohm here, you have 4 ohm resistance here. Okay, you have one more 2 ohm resistance here, and then you have then IX. Okay, 8 ohm. So now this 5 ampere current is coming here. Okay, and out of 5 your 3 ampere current is moving here. Okay, let it be. So it is question they're asking what is the value of Vx. Okay, so you need to find out here Vx. Okay, so tell me how will you find out Vx? Nothing is given, only the current is given. The current is coming 8 ohm. Tell me how will you find out? Determine Vx. Determine कैसे करेंगे इसको? Now just look at this circuit. Okay, so here voltage drop is 60 volts. यहाँ पे कितना voltage drop है?
40 volt.
40 volts. Okay, because current is 5 ohm. So here we have voltage drop of 40 volts. Okay, plus minus 40 volts. Now I know 60, I know 40. Can I calculate this one?
Yes, sir.
Because now I can apply Kirchhoff's voltage law in a loop. So in loop, out of 3 voltages, I know 2 voltages. So remaining voltage I can calculate what is the voltage here. So apply KVL in first loop. Okay. Apply KVL. Okay. So how will I apply KVL? I write minus. Okay. Then this is a drop plus 40. Okay. Say this voltage here. Say voltage at V10 ohm equals to 0. So V10 ohm is equals to how much now? 20 volts. The remaining we have 60 here. Out of 60, 40 will be dropping here. Remaining 20 will be dropping here. Okay. So I know now voltage drop across this 20 volts. Okay. Now what I can do? Now what should I do? I want to find out this Vx.
सर अब 20 वोल्ट हमारे पास आ गया तो फिर हम
What you can find? Now if you're 20
4
volts,
ohm and 2 ohm are in series, and 20 ohm is
no.
parallel.
See, you have 20 volts here.
Sir, current निकालना
सर
है।
करंट डिस्टेंस
Very good. So now you can find what is the current in I10 ohm.
Current is 2, sir.
20 divided by 10,
2.
2 ampere. So now 2 ampere current is coming here.
3 is going up.
So now, so this is 3 is going here. Okay, 3 is going here. So 3
12 volt.
3 is going here. So this will become what? 12 volts.
12 volt.
This will become 12 volts. Okay. Now you know this
8
voltage.
volt.
You want this voltage. Are you getting now?
Yes, sir. 8 volt is coming.
Okay. So this loop, you know this voltage drop, this voltage drop. Now you can calculate this voltage drop. Okay. So now you can write minus
Minus
20
20 plus 12
plus 12 and
plus IR.
plus Vx. Okay.
Yes, sir.
Plus Vx equals to 0. So
Vx
Vx
is
equals to 8 volt. So this here I am just applying KVL. Okay, nothing more. KVL and KCL. So any circuit can be solved with n number of ways. Okay. So later you will learn very efficient technique where you can easily solve any circuit. Okay. So far just we have learned this KVL and KCL, and I'm only applying those whatever we learned so far. Okay. So in this way I can calculate.
Sir?
बोलिए.
Sir, how did we get the 12? The
12.
12 volt किसमें था?
हाँ, so यहाँ पे कितना करंट आ रहा था? ये कितना करंट है?
5 से
5 है। यहाँ पे वोल्टेज ड्रॉप कितना है? इस सर्किट में करंट कितना है? इस ब्रांच में करंट कितना है? 2 एम्पियर है। तो बचा हुआ केसीएल से यहाँ नहीं जाएगा 3 एम्पियर। ओके एंड 3 एम्पियर जाएगा तो 3 4 12 नहीं होगा। And always remember this sign. Okay, always remember the sign of polarities while solving any electric circuit. Okay,
sir, minus 20 is because we have taken minus 20 because it is going from positive to negative.
That is your choice. How do you want to make loop? If you move, if you make, हाँ बोलिए।
12 वोल्ट के साथ अगर पॉजिटिव नेगेटिव फिर माइनस 12 नहीं आएगा यहाँ पे?
यहाँ पे नेगेटिव पॉजिटिव का है। Current always moves from higher potential to lower potential.
Higher potential to lower, yes.
So this higher potential, this is lower potential. Okay, so this with this current, this higher potential, you have some potential, you drop, and you get remaining here, this potential drop here. Okay, so this is lower potential. This is always 0 reference. What is the actually confusion?
सर -20 + 12 एंड प्लस Vx
Yes, yes.
इसमें
हाँ.
सर -20 higher
Minus,
potential to the current is flowing
no,
higher potential to lower
how
potential.
how you are moving across the loop. तो आप लूप में ऐसे मूव कर रहे हो तो पहले आपको क्या मिलेगा? माइनस नहीं मिलेगा.
Okay, minus.
So this is
Okay.
voltage rise ना, and I'm always writing voltage rise as a negative.
Yes, yes. Okay, okay, okay.
Voltage rise is negative, voltage drop is positive. This is a voltage drop, so I'm writing positive. Voltage rise, I'm writing negative. Okay, so you can do opposite way. You can write voltage rise is positive and voltage drop is negative. So minus, so you can write 20 minus 12 minus Vx. You can write. Okay, so same thing. Okay, so there should not be confusion. This is the first step. Okay, you must know how to apply KVL. If you don't understand, then
सर
हाँ
सर एक -Vx नहीं आएगा फिर?
भी क्यों कैसे माइनस Vx आएगा? भी अब यहाँ जो वोल्टेज है वो यहाँ से तो ज्यादा ही है ना. भी ये तो ड्रॉप हो गया. भी यहाँ पे आपका पोटेंशियल आया. करंट कैसे मूव कर रहा है? यहाँ मूव कर रहा है. तो ये हायर
हाँ जी,
पोटेंशियल, लोअर पोटेंशियल, फिर करंट यहाँ मूव कर रहा है. तो ये हायर
Okay.
पोटेंशियल, ये लोअर पोटेंशियल.
Yes, sir.
ओके, यू टू सी करंट ना, करंट डायरेक्शन यू टू फॉलो. This is very small things, but you must be sure about those things. Okay, let me give same question, similar type of questions, plus minus 30 volt. If you have 8 ohm, I'm not putting now plus minus, you have to decide. Okay, if you're getting confused, you yourself decide which is positive, which is negative. 2 ohm. Okay, this is 2 ohm. I want to see this is a current source, say Ix. Okay, now this is a 2 ohm. Okay, so please find out Vx, and you have been given a 2 ampere current is flowing in this branch. Tell me what is Vx now. Exactly same way, same question. So what should I know? So if I want to know this one, okay, what should I know? I should have a knowledge about this voltage, this voltage. There are 3 voltages. If I know out of 2 voltages out of this 3, I can easily calculate this Vx, isn't it? So in order to know this voltages, I should know what is current here and what is current here. Okay, so here I can apply KVL. I can know what is B10 ohm. Okay, so I have a minus 30. Okay, now current is going from higher potential to lower potential. So this become what? How much voltage?
16 volt.
16 volts.
Sir,
And this is
sir,
say
0.8 volt.
so this is 10. Okay, so this becomes 0. So V 10 ohm कितना हो जाएगा आपके पास में? This become 14 volts. Okay, 14 volts. And if you want to calculate how much current is flowing out of this 2 ampere current will divide. So how much current is going here? That will be I 10 ohm will be how much? 14 divided by 10 ohm, 1.4 ampere. Okay, that means remaining 0.6 ampere will flow here. 0.6 ampere.
8.
Okay, now you have voltage drop here. How much? 14. So this is your 14. Okay, 14 volts. Again you apply here KVL. Apply KVL. Okay, here also you are applying KVL. Apply KVL. Okay, so you start from here minus 14. Then
1.2.
1.6 into 2, 1.2 volts. Okay, let me write here 2 into 0.6. Okay, and then finally
Plus Vx
Vx equals to 0. Okay,
12.8.
so Vx equals coming 12.8 volt. So final conclusion, okay, you have to decide polarities, okay, and then you have to write KVL, the algebraic sum of voltages across 0, okay. So this is voltage rise, voltage drop, 0, okay. Similarly here, this is voltage rise, voltage drop, okay. The sum of voltage rises equal to sum of voltage drops, and you can apply KVL and you can solve. Okay. Now put the heading voltage division in series circuits. Okay. So if n number of resistances are connected in series, say this is R1, say this is R2, R3, say this is my Rn, and I am applying a voltage, say V, okay. Say here voltage drop is V1, V2, V3, and say this is Vn. So I am assuming the circuit I current is flowing. This battery is giving I current to this circuit. Okay. Now I'm moving in a current direction, so this will be voltage drops always. This will be voltage drops always. Okay. Now if I apply KVL, in the loop, what I can write, I'll start if I'm moving in the direction of current, okay, I'm starting from here, so I'll add minus V equals to plus V1 plus V2 plus V3 plus Vn equals to 0, okay. Sum of voltages equals to 0, okay. Now this will give me what? This will give me V equals to V1 plus V2 plus V3 plus Vn, okay. Now what is the value of V1? What is the value of V1?
IR1.
IR1, okay. Now V1 is IR1, IR2, IR3. So put the values here. So if I put the values here, I can write V equals to IR1 plus IR2 plus IR3 and IRN equals to, so this is equal, okay. Now total, if I say that the total equivalent resistance of this, so if I can take common, so I can write what? I equals to R1 plus R2 plus R3 and say Rn, okay. Now if I write this is a R equivalent, so this will be my V will be I equals to R equivalent, okay, and R equivalent will be in series when resistors are in series. So the R equivalent will be equals to R1 plus R2 plus R3 and Rn, so on, okay. And suppose if we want to find what is V1, so V1 will be I R1, V2 will be I R2, okay, so on. So it's simple, okay. So let me discuss, give you one problem. So how can you find I here? How can you find I?
V1 by R1.
How can you find I here?
B upon R. V1 upon R1.
So V upon R equivalent. Huh? V upon R equivalent.
R equivalent.
Okay. So if you want point I, so into R1. So V2 will be what? V upon R equivalent R2. Okay. So let me give you a simple circuit and ask some questions so that your basic should be clear. So I'm giving you a 20 volts battery. Okay. I'm connecting say 2 ohm. Okay. This is 3 ohm and this is the 5 ohm resistances here. Okay. So now can you tell me what is the voltage at this point? What is the
10.
say this is my A, say this is B, this is C, and this is D. Okay. So what is the voltage at point VA? A
10.
is it 10 volts because this is directly connected to 10. Okay. What is the voltage of B? What is the voltage at B?
8 volt.
8 volt. Okay. Because the current in the circuit, you know, the voltage is this one and R equivalent is 10. So current in the circuit is 10 upon 10. Current is 1 ampere. Okay. So in the beginning you have 10 volts here and I current is flowing, that is 1 ampere current is flowing. So after you will have voltage drop of 2 volts. Okay. Here you have voltage drops of 2 volts. Okay. And so remaining 8 volts is come here. Okay. So VB will be your 8 volts. What is the value of VC? What is the value of VC? 5 volts. Okay. 3 again, 8 out of 8, 3 volts will be consumed here. And if you say VD, what is the voltage of VD?
0 volt.
0 volt. Very good. Okay. It's connected to battery that directly. So in this way, you can.
प्लीज जरा बताइए कि एक बार VB 8 वोल्ट कैसे आया?
कौन सा? VB.
हाँ.
So you have 10 volts here. VA is 10 volts here, and the voltage drop across 2 ohm is 2 volts, isn't it? यहाँ पे voltage drop कितना है? करंट है 1 एम्पियर, 2 वोल्ट है, तो यहाँ पे you have 10 वोल्ट, उसमें से 2 खर्च हो गया. Okay, 2 are consumed, remaining 8.
Okay, sir.
Okay.
Yeah.
3 is consumed, you have 5 here, this is 5 here, like this. Okay, the simple, this you have done in your school, and I'm not teaching anything new right now. Okay, so this was your voltage in series circuit, voltage division in series circuit. Okay, now I'm going to do current division in parallel circuit. Very important topic. Please carefully understand this topic, because this we will be using again and again in our course. Well, I will discuss the transistor and operation amplifiers especially, and even diodes. So current division in parallel circuits. Okay, so now suppose I have n resistance in parallel. Say this is R1, say this is R2, this is R3. Okay, and we have this Rn resistance here. Okay, and total current in the circuit is coming I. Okay, so this I can be, okay, say I am putting a voltage source here which is giving me I current. Okay, and these all circuits are in parallel, so I'm assuming the current is dividing here I1, current here is I2, the current here is I3, and the current here is your IN. Okay, and how many nodes are there in the circuit? Circuit में node कितने हैं? One node. Okay, so this is the total one node. Okay, this is the one node. So apply apply KCL at the node. Okay, so if I apply KCL says incoming current is equal to outgoing current. So in this node, incoming current is I and outgoing current is I1 plus I2 plus I3 and IN, isn't it? Okay, now if I write, now if I write I1, what is the value of I1?
V by R equivalent.
Okay, V by, because these all resistors are parallel, so voltage drop should be same. The voltage drop here is same like here, voltage is same like this point, because there is no resistance, no voltage is getting drop consumed in this point, so voltage of these all points are same. Okay, so if I want to write I simply can write V upon R1, V upon R2, V upon R3 and V upon
सर
हाँ बोलिए।
R1 के टर्मिनल पे VS ही आएगा ना, मतलब
हाँ
पूरा
VS
का पूरा
VS लिखो,
जाएगा।
VS लिखो या V लिखो, this VS. Okay,
ठीक है, नहीं उसमें कंफ्यूजन।
okay. So now you can write what? You can write I equals to, you can take V common. Okay, you can put 1 R1 plus 1 by R2 plus 1 by R3 and 1 by Rn. Okay, now this what you can write, you can write this V is equal to R equivalent. Okay, so where R, when the resistance are in parallel, their equivalent resistance is given by like this, 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3 and 1 by Rn. Okay, now suppose if I want the current I1, total current is I, so what will be I will be your V upon
R1.
R1 और B क्या हो जाएगा?
I into R equivalent.
B equals to I into R equivalent from this equation. Similarly, if you want I2, okay, you can simply write I into R equivalent upon R2. And in general, if you want IN, so IN you can write how? You can write I, okay, into R equivalent of the circuit divided by Rn. So let me, so here I have taken n resistors in parallel. Okay, now we generally come across when two resistors are in parallel. Okay, so how to write this equation for two resistors? Okay, so now suppose I have only two resistors, say total current is coming I and I have two resistance. Say this is R1 and this is R2. Current is dividing, current will always divide in parallel circuits. Okay, series current will be same. So this I1, I2. Now I want to write what is the value of I1. So what is the value of I1? Total current into R equivalent upon
R1.
R1. Okay. So now what is the value of R equivalent here? What is the value of R equivalent?
R1 plus R2 upon R1 into R1.
So R1 into R2 upon R1 plus R2. Okay. So this will give me what? I1 equals to I upon R1. Okay. R1, R2, R1 plus R2, R1 cancel. So you have I1 equals to I into R2 upon R1 plus R2. Okay, so this is a very important, you can say, expression or formula, you can remember as a formula. Similarly, if I want I2, what should I write? I into
R equivalent.
R2 on R1 plus
Yes, sir.
R2. Okay, so this is a very important formula because we will come across.
Sir,
The I into R1.
R1I.
Okay, so we'll come across these things again and again. So suppose you have been always, you will be asked, some current will be coming and you need to divide this current into two parallel circuits. Okay, so what you do, you will take total current, and if you want current in this branch, you will take resistance of opposite branch. Are you getting my point? If you want I1, okay, current in R1 branch, so you will take the resistance of opposite branch R2, and then you will take simple sum of these resistances, not parallel sum, only algebraic sum, simple sum of these resistances. So if I want I1, I will take resistance total current into R2 and sum of these resistance R1 plus R2. Okay, similarly, if I want current I2, I will take opposite branch resistance R1 and then sum of these two branches resistance R1 plus R2. Okay, so you have to always apply this thing. So let me give one question. Suppose a 5 ampere current is coming here. Okay, and the resistance are given 10 ohm. This resistance is 10 ohm, and this resistance is your 15 ohm. Okay, so find current in front I1 and I2. Please calculate current I1 and I2. So if I'm moving fast, please stop me. Okay, because these are very simple things. So I hope,
I1 3 ampere, 2 ampere.
yes. So if I want current in I1, okay, the simple thing, I will take total current IT, okay, which is equals to 5 ampere here, total current into resistance of opposite branch 15 and the total resistance of these two branches 25. Okay, so this become 3 5 1. Okay, so I'll get 3 ampere current, and remaining current I2 will be 5 minus 3. 5 minus 3 equals to 2 ampere. Okay, now if you want, you can apply formula, but these two branches are there, so you can find the current in one branch, and remaining you can calculate by subtracting this current from total current. Okay,
Yes.
okay, give me one more question, small question. Can I erase this one?
No, sir, only 2 minutes.
Please stop me. If you want me to stop, please inform me.
Sir,
Hmm.
sir, how there is one note? So please explain.
What do you think?
Number of nodes.
Number of nodes.
Yes, sir. I have confusion. Like why there is one node?
So tell me how many nodes are there in the circuit?
Sir, there is a voltage source in the last question.
So let me put voltage source here.
Yes, sir.
You say this is voltage source. Okay. So now how many nodes you can see here? How many terminals you can see first? This is the A terminal.
Yes, sir.
B, C, D, E, F. Okay. Now tell me what are the how many nodes are there in the circuit?
So the ABC are same
Yes.
and D, E, F are same.
Yes.
So there are two.
Two nodes only. Okay.
Okay.
So now why these are same? Because they have the same potential.
Yes, sir.
Okay. Suppose 10 volts is coming here. This is connected to this point. and there is no resistance, no any equipment, no any component. So this voltage will not drop. These are zero resistance. They are short. These all points are short to each other. Na?
Yes, yes.
Short means there is no voltage drop. Okay, they are all one point. They are single point. Okay, so this will be considered as a single node. Okay, similarly these are considered these are connected together. They are shorted. This is other node. So there are only two nodes.
Okay, sir.
Okay, so let me give one more question. Okay. This is 3 ohm, 6 ohm, 9 ohm, 12 ohm, and total current is coming 5 ampere. Okay, so find the current in each branch. Now here more than two resistors are there, so that logic you cannot apply. Current in this one is equal to current like this, you cannot do. Okay, so now you have to calculate what
R equivalent.
R equivalent. Okay, now it is more simpler. If you have more resistance, what you can write, you want say this is I1, say this is your I2, this is your I3, and this is your I4. Okay, so either you convert these into two resistors, right? Okay, and then you do one by one. Okay, either or other way is what, so you take this resistance and take equivalent of this one, then you can find the current here. Then you take resistance this one and equivalent of these three resistance, and you can apply the two resistor formula here, but that is not necessary. You can simply write, if you want I1 is simply what, total current into R equivalent upon R1. Okay, so what is the R equivalent value here in the circuit? 1 by 3 plus 1 by 6 plus 1 by 9 plus 1 upon 12. Okay, if I take 36, 1 upon R equivalent, 36, this will give me 12, this will give me 6, this will give me 4, this will give me 3. Okay, so 18, 725. Okay, so my R equivalent is 36 by 25 ohm. Now calculate I1, I2, I3. Okay, so if I want to find I1, okay, I can simply write this 5 ampere total current. R equivalent is 36 upon 25, and my resistance R1 is 3. Okay, so this become 5, 1, 5, this become 3, 1, this is 12. The I1 is 12 upon 5 ampere. Okay, similarly, now if I want I2, please calculate I2, I3, I5.
So I2 is 1.2 and I3 is 0.8.
Okay, and I4,
0.6.
okay, very good. Okay, so we have this 12.5, I1 is 12.5. Okay, if I calculate I2, that will be total current R equivalent 36 upon 25, and the resistance is 6, 1, 6, 1, 5, that is 6.5, that is 1.2 ampere. Okay, and if I say on I3 will be how much? Total current R equivalent is this one, and resistance is 9 ohm. So 1, this will be 4, this will be 1, this will be 5, this will be 4 by 5 ampere. Okay, and similarly if I want I4 will be what? Total current 5, 36 upon 25 and upon 12. This is 1, this is 3, okay, 1 upon 5, so 3 upon 5 ampere, okay. Now if you add this 5, 3 by 5, 4 by 5, 6 by 5, 12 by 5, okay, so 12 plus 6, 18, 18, 18, 4, 22 and 3, 25, 25 divided by 5, total current will come 5 ampere. So I like to stop here because no, we cannot continue more and more techniques here. Okay. So are you getting what we are doing here? Any doubt?
No, sir.
Today's class. Okay. So this is the disadvantage of doing online. So online has some advantage, some disadvantage also. If you want to do lot of problems, then this platform is not suitable. Okay, we cannot move. We can do so many things in one class. Okay, because so we are stopping here. Okay, today. Okay, and next
Okay,
class. So what we have finished. Now we have finished our basics laws. Okay. Now from next class onwards we learn techniques, okay, like how to solve circuit with nodal analysis, okay, and then mesh analysis, and at the last we'll take one theorem at a time, and we'll see how efficient those theorems are, how this saves our time. If they're now we are solving simple circuits, so once the circuit become complicated, then we will understand the advantage of different methods and different theorems. Okay, thank you very much for having patience.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.